taking a look at this problem that we did as our test-like questions, we have a parabolic trough that is 20 feet wide and 10 feet deep. And so kind of superimposing it on an XY axis, either remembering that this is the equation for the generalized formula for a parabola where h comma k is the center, or just the fact that y equals ax squared is the formula for a quadratic or a parabola that is centered at the origin. What I have though is I have a point right here that this parabola goes through. That is, so if the distance across is 20 feet, this is 10 feet. So on the x-axis, 10 feet over, 10 feet up. So it goes through the point 10 comma 10. Plugging that into my equation, I have 10 equals a times 10 squared, or 100a equals 10, a equals 1/10, just divide both sides by 1/10, or by 100. So now my equation is y equals 1/10 x squared. The question then asks, when the distance across here, what is the distance across when the depth is 5 feet? So now I have a depth here that's 5 feet, or in terms of the xy axis, this is 5. What is the width? So we're going to use this equation, 1/10 x squared. So 50 multiplied by 10 equals x squared. Take the square root, x equals the square root of 50, which is, remember, that's square root of 25 times the square root of 2. X is going to equal 5 square root of 2. But that is the x coordinate right here at that point. So it's square root of 5 square root of 2 over, 5 feet up, that's that point. So this distance from the center line to the edge is 5 root 2, and the total distance across will be double that. So the width will equal double that, so 10 square root of 2. Obviously, you can use your calculator to find that out, but I did this without my calculator, so I'm going to leave it as 10 root 2. Second part of the problem says, identify what you know about this equation. So looking at things like, where are my zeros going to happen? So when I put 0 in for x, 0, 0, I have 2 over negative 5. So when x is 0, it is negative 2/5. So my y-intercept is at negative 2/5 up on the y-axis. All right. Then I think of 0 as like, okay, I need to know what my x-intercepts are. Where does this function equal 0? In other words, where does 3x squared plus 2 equal 0? So subtract 2 from both sides. 3x squared equals negative 2. X squared equals negative 2/3. X equals the square root of negative 2/3, which is equal to I times the square root of 2/3. So there are two imaginary roots, but there are no real roots, so there are no x-intercepts. So here I have no x-intercepts. But I do have, however, two imaginary roots. All right. Asymptotes occur when the denominator is equal to 0. So I will have a vertical asymptote at x equals 5. Because when I put 5 into here, 5 minus 5 is 0. I have 0 in the denominator. I have a vertical asymptote. And then shape. Oh, and then long run. I'll do long run behavior first. So long run behavior is always determined by the coefficient of the largest power. In this case, my largest power is in the numerator, squared. And really when I'm doing long run behavior, I'm going to look at the numerator and denominator together. I'll do that as a separate little fraction down here. 3x over x, 3x squared over x. As x gets really large, so we say the limit as x approaches positive infinity, my equation will approach positive infinity because the larger the value is. I go for x, I square it, even though this x is in the denominator and they reduce, I still have 3x. I'll rewrite this. I still have 3x, so as x gets really big, the function gets really big. The limit, so that's the first half, the limit as x approaches negative infinity is also negative infinity. So as my equation gets really large, my function gets really large. As it gets really small in terms of negative infinity for x, the function approaches negative infinity. Shape then looks at, and we're going to see some things when we talk about this in the future, x squared is parabolic, which means there will be an aspect of this that will be semi-parabolic, but there's going to be what's called an oblique asymptote. Again, we're not there yet, but we're going to be there probably in the next day or two, in which case then we'll see it's kind of like a parabola sorta turned on its side. That's enough for now. But for what I was looking for today was the intercepts here, imaginary roots, asymptote, and then the fact that as I go towards infinity in the x's, the graph goes up. As I go towards infinity in the negative direction on the x-axis, my equation is going to end up going to negative infinity over here. Lastly, I need to do either long division or synthetic division. What I'm going to do is show you how to do this in the long division form. First thing first, I need to write the equation in standard form. And the biggest mistake people will make is they forget to put the 0x because there's not an x term. It goes 3x squared down to constant. You have to have this middle term. And then I'm going to go ahead and write the then divisor, x minus 5. And then starting at the top, x goes into x squared, but I need this to be exactly the same, so I need to have a 3x up here. I'm going to take 3x times x, giving me 3x squared. I'll have 3x times negative 5, giving me negative 15x. Going to subtract the whole thing. So that's 3x squared minus 3x. That gives me 0. I have 0 minus a negative 15x. Minus a negative is positive, so it'll be plus 15x, and then I bring down the 2 plus 2. I write this 0 here, but it doesn't exist, so I'm just going to erase that there. And then I'm looking at and saying, okay, x needs to go into 15x, so that will be plus 15. 15 times x, 15x, 15 times negative 5 is negative 75. Subtract everything, and I'll have 15x minus 15x is 0x. 2 over negative 75 is negative, I'm going to go blue, negative 73. So I have a remainder, so that means my final equation is going to be 3x plus 15 minus 73, oh, that's a 5, 73 over x minus 5. So it's a remainder of this out of that. Oh, sorry. Minus, I just realized this. Minus a negative is plus a positive. So this should be a positive 77. It doesn't change much. I mean, I still have a remainder. It's just 77 over x minus 5. Sorry about that. All right, so there we go. That is my final answer. And that should do it for now. Hopefully this all makes sense. If you have any questions on this, obviously catch me before, after, or some other time about the solutions to these problems.